All right. Hey, everyone. I get to do double duty today as I can actually go in this full screen mode. Wait a second. Yeah. Help greet everyone on their way in. Also going to be talking today about the secure development lifecycle. And it's funny to be presenting on this today because I think I signed up to do this talk like 6 months ago. And since then, we've actually been rolling out the SDL to all of our development teams at NI. So those of you from NI who have been hearing about this so much that you're totally exhausted with the topic, I apologize. But hopefully this is something that will be interesting and new for some of you folks. And maybe just real quick, like a show of hands, how many of you work in like software development on a development team? All right, yeah, all right, good number. All right, very good. So this hopefully be very relevant to y'all. But also, if you're doing IT and you do IT internal development, this might also be very relevant. So a little bit about myself. I'm a chief product owner in SystemLink R&D. I focus a lot on IT security and infrastructure. I've been at NI, now Emerson, for about 17 years, been in many different roles from support to development, engineering management, product ownership, generally all in the cloud and in the web space. Really started getting into security about 4 or 5 years ago now, after helping to lead a big project to modernize our identity and access management, role-based access control system in the software that I work on. A little bit more about that in a minute. Helped to author our 1.0 version of our SDL. We're way beyond that. There's definitely some of our leaders in the back of the room who've been helping to mature that and rolling that out. And nerdy in many different things from volleyball to quantum mechanics. I just can't get enough quantum mechanics videos on TikTok.
Certain or uncertain?
Wait, say it. I misspelled something on here.
No, you're quantum mechanics.
You know what? I get frustrated by some things in quantum mechanics, but maybe we'll leave that for another talk. I'll start going on for that. So I mentioned I work on SystemLink. So this is smattering of 2 slides of what SystemLink is all about. But so at NI, we make a lot of hardware and software that people use for physical system testing. So we might be testing the batteries that are going into your new electric vehicle. We might be testing the semiconductors that are going into a power amplifier in your phone. But this software, SystemLink, is an adjacency to the work that a test engineer might do. They're managing these big, expensive test systems. They're producing lots of data. And this is a piece of enterprise software that helps us push software down to those systems or collect data off of those systems and do something interesting with it. And because of the place that it sits, it actually has more exposure to security needs than some of our other software had been in the past, although that's rapidly changing. So I mentioned I helped lead a big identity and access management rewrite of SystemLink. And around the same time I started doing that, I started engaging more with our sellers as they would interact with IT folks in order to be able to take some more of those questions, because I was beginning to ramp up and do more in that space. And I started filling out these security questionnaires, and folks like Kyle in the back has been doing this probably a lot longer than I have. This is actually a pretty simple one. I think the latest ones that I've been filling out are even more sophisticated than this. But it would start asking these questions that made us really uncomfortable. Are we doing security reviews? Are we doing penetration testing? Are we doing code reviews? Are we scanning our code? And as we went through this list, I started realizing, wow, there's a lot to security that we don't understand. We could not answer affirmatively to all of these questions. Even if we could to a few of them, we got through the entire security checklist. It became very difficult. And so, I started Googling. It's dangerous. It's like, hey, what should we worry about? I wanting to learn more about security. What does security mean for us? And it's like, oh, well, there's these 9 things that we need to keep in mind, okay? 9 things, keep Googling. Actually, there's 10 things, okay? 10 different things that we should worry about. Well, actually, I don't even know how many numbers, how many things are on here. It's like, oh, there's even more that I have to worry about. Are these things overlapping? I don't even know. All right, we're back down to 10. Okay, that's good. It's a different 10. And maybe there's only 6, and the 10 is too much to think about. There's 6 things that I need to be thinking about. And I guess here's another 6. I think this is a different 6. And then there's like folks like Dr. Anton here on Twitter. I don't know if you guys follow this guy. He's an interesting guy. And he asked something, and I'm like, I don't even know what half of this stuff means. And it's just so ridiculous in the curse of knowledge. And I don't know what's more like out of touch, like his tweet or that first response, which I just like, I don't even know. Like I'm so completely out of the loop. How in the world am I supposed to secure our product? There's so many things to think about. There's so many things to reason about. And it can really feel like the whole world, the whole mountainside is on fire. Like, oh my God, what are we going to do? We need to make secure products. I look around on the internet, it means a million different things. How do we actually go about securing our products? So that's what this talk is all about. What do we need for product security? I'm missing a word there. And then how does NI incorporate this in our product development? And finally, how do we create a security-centric culture? So let's get a little bit into the why. So what does product security mean? So these are the big three things that it means. It's the processes that we're using to design and develop and build our products. And that could be a lot of different things. So the whole design of the product. And of course, there's features, authentication, encryption. There's actually security features that are in our products. And then finally, there's the support that we give our customers. And you can think about run-of-the-mill support and also things like incident response. But while doing this work and while working on some different working groups within NI, we started talking more about the SDL, or the Secure Development Lifecycle. And there's a lot of different acronyms. You can see this presentation refers to it as SDL. You might see SDLC or Secure Development Framework, some of these different things. And this is a quote from Microsoft, an interesting quote, right? So it's practices that allow us to focus on security requirements, security assurance, and it reduces cost, which is a really funny thing to think about, especially if you've never done secure development. You're like, here's this new practice that we're going to put in place that's going to make things cheaper. And you're like, you're asking us to do more. How in the world is that cheaper? And there's sort of two parts of this. One part of it is if you look at traditional waterfall development, security maybe have been pretty close to the end of that waterfall and could cause a lot of rework. Oh, hey, you guys didn't do this or this or this. It needs to go back up to the design phase and trickle back down the waterfall. Clearly, that's expensive. But in modern agile software development, we're more insulated from those types of problems, but there are incidents. And whenever there's an incident, we're going to drop everything and do what we can to resolve that incident. And that's always expensive to do. If we can prevent that incident from occurring, that should lower our costs. And that's where that whole cost structure comes in. But furthermore, like why do we need to have an SDL? It is an industry best practice, an increasingly mainstream best practice. There's executive orders from the US government. This was an executive order from the Biden administration that was in response right after the Continental Pipeline hack and also the SolarWinds hack had happened not too long before that. And you know, the flip switched in the federal government. Hey, we're going to do what we can to require more cybersecurity. This particular executive order is very focused on companies that sell into the government, which in our particular industry has plenty of exposure to. And the big one, the one that's driving a lot of discussion, the one that's driving us to standardize this across all of our development teams at NI is the EU Cyber Resilience Act, or the CRA. We'll talk a little bit more about that. Of course, there's things like risk and cost reduction. I spoke to that just a moment ago. But increasingly being able to establish and protect trust. Think about companies like Apple. Apple has made it part of their DNA to sell trust. Oh, we're the most secure, we're the most private. And it's incredibly important to be able to speak to that in order for your product to be viable in the market. And to a large degree, the reason that we went down this path in the first place was to protect the viability of System Link. And of course, it's increasingly required to do business. That goes hand in hand. If our customers won't do business with us because we are not doing secure development, we're not producing secure software, secure products, they're not going to buy from us. They're going to buy from our competitors who are doing these things. And so it's increasingly less of a competitive advantage and more table stakes, but everyone has to do this. So a little bit more about the CRA. This is a summary of some of the things, if you were to dig through like the annexes of the CRA, you'd see, hey, it has all of these different things that need to be done. You know, during design, these are a whole bunch of things that you need to be thinking about. And of course, during operation, there's a whole another set of things that you need to be thinking about. And with the EU CRA, the way that it's structured is that if you're not doing all of these things, you could be locked out of the European market. So the CE marking you see in a lot of products is tied to this, is going to be tied to this. And so if you can't sell to all of Europe, it sounds like you have a smaller addressable market than perhaps you would like. And then even worse than this is, say you were just like, yeah, we're do this. There's a lot of self-attestation parts in the EU CRA. Yeah, let's say we're doing all of this, but we're not really. The fines that come along with lying about this are extreme, into the millions very quickly. So it's a best practice, establishes trust, legal regulations, all of these types of things are compounding. And in this talk, we're going to talk a lot about secure by design, because in so many ways, all of the things that we do that are on this list cascade from secure by design, right? So if I'm thinking about secure design, I'm thinking about secure defaults, I'm thinking about the due diligence of my supply chain, for example. And one of the things I really, really think is important to stress is this notion of what the SDL is for and what it helps us produce ultimately. And this is the difference between secure features and security features. So we mentioned some security features: encryption, login, MFA. There's a whole smattering of them, right? And they're important topics, and they're really critical that you do them well, and that you adhere to standards and align with industry best practices in doing them. But honestly, while an exploit could come through, you know, a security feature, in many ways an exploit comes through just any feature. Any input field in any piece of software could be a place where you could execute cross-site scripting, for example, or a SQL injection if it was connected to a database. This could be desktop software. There's plenty of desktop softwares that directly connect to a database. And of course, web software, we think about this type of stuff a lot. And so when we employ the SDL, we want to employ it across all of the things that we're doing, because we want to assume that anything that we're building, anything that we're producing that our customers could use could lead to an exploit. And what are we doing to help to mitigate that from happening? So it applies to every feature. So let's get into the how. What does this process actually look like? So we decided to create an SDL, and we started small, and I recognized myself, someone who's early in my security journey. I'm not a security professional. I have very little credibility when it comes to actually making decisions of how do we create secure products. So what do you do in order to do that? You look at what industry is doing, and you look at your leaders in industry. So a big one is Microsoft. Microsoft has a lot of really excellent material on their website about the SDL. They apply this process to all of their software development. Recent memos from the CEO is having them double down on these types of things. And it was a really essential resource for us to be able to get started. And we were turned on to this because one of our teams that we got through an acquisition said, oh, we're doing Microsoft's SDL, which is a really great place to start. I think what we practice now is a modification on that. It's more contextualized to our business, but it was a really, really excellent starting point. And then, of course, there's like the thou shouts of security. You should do this and not this. And a lot of that is coming from OWASP, and we'll talk a lot about that later in the talk. Cannot stress enough how important OWASP was to be able to quickly ramp us up into the policies and requirements that we must meet in order to truly have secure software. Then there's things like the NIST Secure Software Development Framework, 800-218, familiar with all the numbers. It is a really incredibly rich document. There's tons and tons of details in it. It's not written quite like a process, but it is a document I frequently refer to, and it's like, hey, we're doing pretty well. What's the next thing that we could be doing to continue to mature our practice? And there's things that are described in the NIST framework that we try to bring in and incorporate. And of course, if you look at lots of different security certifications, 27001, 853, 62443, am I getting that one right? Which I think is the embedded one. They all talk about very similar things. They have overlap with one another. But they all come back around to this idea that you're doing secure development and secure by design. So being able to adopt this practice, even if you're not pointing yourself towards a very specific certification, it will give you a leg up to be able to achieve any of those certifications. And the certification you achieve might be informed by the business that you're in, the industry that you're in, for example. So there's a lot of practices in the SDL, and this is part of, some of the things that were hard to grok as I began this journey. Oh, there's so many different things to think about. There's these tools that we need to think about. There's vulnerabilities, there's different types of exploits, the OWASP top 10. How do we kind of wrap our head around all of these different things and apply a single process in which we can do many different things? And that's really where the SDL sings. So we have these many different practices that make it up. Secure training. So, what is the SDL? We give versions of basically this presentation to all of our engineers very recently to help ramp them up on what the SDL is and some of the practices within it. Not to mention, if there's new tools available on the market, we might be developing or acquiring more training in order for people to be able to be aware and informed on what we're asking them to do. Using approved tools, pretty straightforward. Hey, if we're ensuring that everyone is using, a common build pipeline infrastructure, we don't want you to go and grab some random one off the web because there might be a lot of policies and hardening that has gone on to ensure that the tools that we're choosing for development are the ones that we consider to be the most secure. I know Jed in the back always likes to point out a really interesting exploit of people just go and download random things off of GitHub and bad stuff can happen. He's absolutely right. And things like using approved tools is not a solution to that, but it might be a mitigation. Secure policies is a lot of the information that we get from OWASP, and I'll go into more detail about that in a few minutes. Threat modeling, which I'm going to go into a lot more detail, which is a really critical part of the practice. And then there's automated tooling. There's a variety of different security tools that we want to incorporate in our practice to help us provide feedback on how we're doing. How we manage third-party components, basically how we manage our supply chain, is essential. And increasingly, a lot of the requirements and regulations that are being developed speak to our ability to be able to successfully manage third-party components. Security testing, how do we test our products to ensure they're secure, and incident response. So I'm going to be going into a few more details about this, but what does the process look like altogether? So this is definitely an infographic. I think you could zoom in and out on all these various pieces and get more detail or less detail. I think if you were to look at Microsoft's SDL, they have a few more steps along the way that break this out a bit more. But this is why it's important to look at, not just what I'm talking about here, but what's going on in industry in order to be able to get a full picture of what could be in this process. So on the left are the things that are always happening, right? We always want to be conducting training. There's always a new hire coming on or a new team that's coming on or new tools that we're hoping to adopt. So we want to be having training available to our teams on this process. And then there's the policy and the practice itself. So we have a SharePoint site, and it's this is the NISDL, and this is what it is. And we're always reviewing that. And you want to be able to review it at least annually. We've done that. There's been so much movement here at NI recently that we recognize that we're probably going to be doing these updates more than just annually. In fact, Kyle and I were just talking about how in 2 weeks, we're going to do a big update to how we're arranging our policies so that more of our teams get more exposure to particular policies we think would be useful to them. And the last one that's always ongoing, although we wish it wasn't, is incident response. So our software is out in the wild, new CVEs are discovered all the time. You have to have a mature practice in order to be able to respond to that and be able to say, push a patch out or produce a CVE, those types of things. But into the practice itself, this can generally be mapped to an agile cycle or iteration, whatever the word you want to use. And I'm just going to run through this pretty quickly because we're going to go into more detail on a few of these. So the first thing that starts is with threat modeling. So when you're designing your software, as early as possible in the design phase, we want to think about things that could go wrong, the threats that it could affect it. And then as we're building the software, both when I'm at my desk or when I'm in a build pipeline, I want to get feedback on the software that I'm writing. So there's a variety of different security tools that may be in the mix at that point. When something goes into PR, a tech lead might be asking you hey, Are you sure you know what you're doing here? You should probably validate that input. Or, hey, we agreed that you are going to mitigate this threat in this way, and I'm not seeing it here. So the discussion that started with threat modeling continues perhaps in the pull request. And then as things go into build pipelines, there's more automated tools that get run and provide us feedback. Perhaps a new CVE is found and it blocks a pipeline. We have to upgrade a dependency before we can move on. As things move out of pipelines and into environments, if you have software that can run in an environment, which like enterprise software, service-oriented architectures tend to be, you might execute dynamic analysis tools on that to get further feedback on the, how well something responds to fuzzing, or if there's a CVE that was discovered in a running container, so on and so forth. As we get ready to release, we want to do a final review. Did we do all the things that we said in the threat model? Did all of the things that we did over the course of development invalidate any part of that threat model? That needs to be reviewed. And then finally, if there's outstanding work, we remediate it, try to mitigate it, or in some cases, you have to accept it. And it's generally those types of, when you do accepting things, it's like, oh, yes, there's a vulnerability, perhaps in a dependency, but maybe I can't reach it, so it's okay. Provide an attestation. Finally, you ship the software. And with that, it's producing things like SBOMs, notices, license files, all of that. So every feature that every development team ever does eventually should churn through this process. And while there's no perfect security and there's no perfect process, this helps remind us or incorporate tools many steps of the way that help to harden and improve the security of whatever it is that we're building. There's a lot going on here. There's a lot of things to think about. And one of the things that's really incredible and really important about the SDL as a practice generally and how it's viewed by industry is that it has maturity associated with it. So this is an example of just some product. And you can see that there's these various things that we're doing, and some of them are more mature. They're more well adopted. The team is better at it. And other things maybe aren't happening yet. We need to go and procure something from our vendor. We just didn't get to our point in our backlog to implement a tool that's going to help us out. And that's okay. We have to admit to ourselves that to be able to do secure product development, teams need to be afforded the ability to learn. Organizations need to be afforded the ability to learn. And by accepting the fact that there's maturity, and maturity is going to happen and it's going to be kind of lumpy as it happens, is a really important thing to keep in mind. And hopefully this lowers the barrier to being able to adopt the process altogether, because we don't have to adopt everything. We're going to try to adopt the process, and we're going to build over time and get better at this. So let's talk about threat modeling. Threat modeling is bedrock to secure software development. Y'all are probably familiar with the Agile Manifesto, especially folks who are in development. Agile Manifesto, I've seen some nods. Threat modeling has a threat modeling manifesto. It's actually structured in a very similar way. There's like, hey, these key questions you want to ask. They have these values, right? So the things in bold, they consider to be more important than the things that are not bold. They're both important, just one is even more important. And of course, there's a set of principles. They're kind of long here. I won't read them all out. But you can go and check out the threat model manifesto.org, has all this information. I think I just copied and pasted it for the most part, along with a lot of other details. But it really tries to explain why this process is so important and why it's so fundamental to secure product development. So like, what is threat modeling as we get into it? And it's a meeting. And it's a meeting probably with the whiteboard. Here we have a picture of a digital whiteboard. This is coming from Lucidchart. This is a couple of threats that, looking at folks in the back of the room, probably contributed to. Had to redact part of it. I realized as I was preparing this, I was like, probably don't want that to just be all over the internet as this gets recorded. But it's a meeting. It's a discussion. And that's the key thing. There's all sorts of tools in the world that make us better, that provide us better feedback. But being able to have a discussion about security between engineers on a development team is the most essential and has the lowest barrier of adoption, because it's just asking questions of what could go wrong here? What could go wrong? What do we do about it? And thinking about bad things happening is generally something that humans are bad at themselves. And threat modeling helps to put us into the mindset necessary to be able to do this. And it's like many skills, it's a skill that as you do over time, you get economies of learning and you become more efficient at it. So a little bit more about the process. Might start with this blank board, right? We have a feature. The feature is to add a new button, something trivial. Or maybe it's a new feature to be able to secure communication between two subsystems over the network. Doesn't matter. We can apply this process to all of these types of things. And we want to keep teams efficient because we're asking them to do this a lot. And so what we do at NI is we select someone to be like a feature lead. Hey, you're going to be kind of the tech lead for this feature. You're going to help to write the design for it. And you're going to help lead threat modeling along with many other things that we ask someone like that to do. And so before they come to the meeting, they do a few different things. They assess the scope of the threat model. Okay, I'm writing a piece of desktop software on Windows. Well, I might consider the Windows operating system to be out of scope because that is a lot of things to think about. It's perhaps not my job to think about securing Windows itself. We might have to make an assumption that an administrator who manages all of these machines at a customer will do the right things to secure Windows. Or it might be a web server or Kubernetes, right? Oh, we're writing microservices that are going to run on Kubernetes. I might consider the Kubernetes control plane to be out of scope because, again, it's a very big thing. I don't want to be focusing all of my time on that. I want to be focusing on the software that I'm building. So scoping is really, really important because you can't boil the ocean. You need to focus on the specifics. Then you apply the applicable security policies. I have a slide on that right after this. We'll come back to that. And then you create a data flow diagram. You saw some of those data flow diagrams. Sometimes those diagrams look like a sequence diagram or like a protocol diagram. Sometimes they are boxes with just lines drawn between them to show the way communication goes. It really doesn't matter what type of diagram you're using. The important thing is that what you're visualizing for your team reflects the scope and also gives them a good idea of how these different subsystems interact, because the way they interact could lead to the different threats that we need to be thinking about. So hopefully all those types of things are happening before we walk into the meeting. There might be some quick review at the beginning of the meeting. Do we all agree upon the scope? Do we all understand the diagram here? Do we agree upon the policies? And then we get into threat ideation. And we use the mnemonic STRIDE for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. There's other mnemonics like PASTA, there's probably a few other fun ones out there. And again, the reason that we use that mnemonic isn't because it's perfect, but it helps to think about, okay, these are bad things that could happen related to spoofing. Does spoofing feel like something that could happen in the thing that we're modeling? Maybe so. I should add a sticky on my digital whiteboard that is like, hey, we don't do TLS validation, so we don't actually know the server we're talking to. We should do TLS validation. As you come up with all the threats, you then decide two things. What's the risk and what's the mitigation? So there may be some threats that we find, but it's like, oh, the risk of this is so exceedingly low. It's good to know about, but maybe we don't actually need to do anything about it. In some cases, there are risks that like, hey, there's an established mitigation. We use the pipeline that everyone uses. The tools that do dependency scanning are already there. Let's just make sure that that's all turned on in our pipeline. Other things might be really specific to the application that you're writing. All right, when someone changes, this setting in this part of our app, are we logging who did that so if we had to trace back, we could determine who that is? All of those different things are threats. All of those are different things that come out of the conversations that people have with one another when we think about bad things happening. And this is why it's so powerful to do this, because there's all sorts of feedback we can get from tooling and responses that we have to do when someone finds something in a running environment. But how do we shift left? How do we think about bad things happening as early in the process as possible? And threat modeling is a very effective way at helping us do this. We use this digital whiteboard. There's amazing tools even to help with threat modeling. We're doing more work with Microsoft, has a Microsoft threat modeling tool that is very useful. We're using those two things together, kind of a pilot phase. But just know that, you could do sophisticated tooling. You could be writing on, one of these big Post-it things, but the discussion that it generates is the really important part. So I talked about policies. Policies are the thou shouts, and I've mentioned this a few times of, where does OWASP and how have they helped us along this journey? And the big thing is the OWASP Application Security Verification Standard. Figured that many of you guys are probably familiar with this. If you're not familiar with this, I encourage you to go look it up because it's a really incredible document. It's basically a big table of, oh, hey, if you're accepting credit card payments, here's a bunch of things that you need to be thinking about. Are you an identity provider? Here's a bunch of things to be thinking about. Oh, here's the things you need to be thinking about when it comes to logging, input validation, and so on and so forth. All of these different categories of what it means to have secure software is it has, all of these types of things spelled out. And so for me, when I was early on my security journey, this was a really important thing to sort of discover and put into practice because this was written by a bunch of security professionals. Maybe even some of the folks in this room or people who presented over the course of the year helped to contribute to this. And it helped ground us into what is good and firm security practices look like. They become the requirements that we see here. So this is a screenshot from our SDL SharePoint. The requirement column comes directly out of the OWASP ASVS generally. There's a few other sources for some controls, some things we even have more internally, but say for like 90% of what you'd find for our policies, they're coming from OWASP right now. We have an identifier for an internal identifier, and then on the right is the external identifier if you need to track down where these came from. But also very important is the control. So when we see a requirement, hey, thou shalt do this, we have to then interpret, well, hey, what does this mean in the context of our software, right? We have strategies that we employ of our software. Oh, we're using API keys to be able to authenticate calls that go between different subsystems. Well, we should probably reference that, right? In the control. We don't want there to be a million different ways that people meet a requirement. Generally, you want as few ways as possible for someone to meet a requirement, probably within a particular software space or a particular application. And that's what the controls help us do. And we, during threat modeling, would have stickies that represent all of the policies that we believe to be applicable to the thing that we're building. It won't be 100% of the policies, but it won't be 0 of them either. And in many cases, as much as possible, we want those policies to have an established mitigation. Hey, there's tools that are already set up that do this. Here's a practice. Here's a microservice that you could use as a model of how this is already working. There's established mitigations. In some cases, it can remind you of things that you need to do. And there might be work items that come out of this that you would have to execute upon in order to ensure your software is secure. So this is a really interesting exercise. So in addition to reading something like the OWASP ASVS, be thinking to yourself, hey, what would this mean if I were to apply this to my organization, or if I apply this to the software that I build? What would be the specifics of what this would mean? And it helps make the security practice a lot more concrete. And of course, there's security tooling. Talked a lot about people talking to each other. It's super important. Security tooling is also really critical in order to create a feedback loop, a continuous feedback loop of how we're doing and doing the things that computers do well that sometimes humans, either through manual coding or code inspection, may miss. So these are the big three. I think you could probably say that there's even more categories, or there's categories within these categories, but I'll mention these main ones. And the first one is software composition analysis, or SCA. This is looking at your dependencies. So when we talk about supply chain management, we think about our dependencies. Oh, is there a vulnerability in Kafka that I need to address by upgrading a version of Kafka? Oh, we're using jQuery in our web app. Is there any vulnerabilities in jQuery that we need to be considering? SCA tools help provide automated feedback on the state of those dependencies. And if you have dependencies where, hey, there seems to be problems with it and there's just no upgrade path, perhaps you need to be thinking to yourself, how do I move away from this particular dependency? The next set of tools is static analysis tools, or SAS tools. So if SCA is looking at your dependencies, static analysis tools are looking at the code that you're writing, right? Oh, it could flag things like you're vulnerable to a SQL injection here. You need to be sanitizing these inputs, and that type of feedback could come in. Things like, oh, you are using pointers in a dangerous way. These types of tools can help to provide that type of feedback. And that's really important, right? We want to make sure that our dependencies are secure. We want to make sure the code that we're writing is secure, because in many ways, our code that we're writing could be someone else's dependency. And finally, the most sophisticated of all of these is the dynamic tools. So dynamic tools might be just sort of crawling over your web application, for example, trying to find inputs and shove things into those inputs, and then read back out, the response of a form page to try to determine things like, is this page vulnerable to cross-site scripting? Possibly. We had a customer ran a DAS tool against one of our products before we had a lot of these types of things in practice, and it showed something. There was a possible vulnerability. All I could see was that the string that it injected showed up in another place in the DOM. And it took some work, but we proved, yeah, you could actually do that, and it could lead to an exploit. And we had to issue a CVE on our product. Being able to have that type of feedback before your customers give you that type of feedback is really critical. And that's why these types of tools are important to incorporate in your development. So many of us who do software development recognize that we are not usually working on a completely greenfield application on day one that we're adopting a new process, right? There's reams of code that have been written for years, maybe decades before we even join the team. And all right, well, what do we do? There's so much feedback that these tools are giving us about the state of our software. How do we address this? And the big thing is to focus on what's in development. Similar to how we talked about scope with threat modeling, we can't have everything in scope. When it comes to the feedback that these tools are giving us, we might have to be more myopically focused on the new code that we're writing than the entire application stack. That might seem crazy to do that, but we just have to be realistic about what we can do as humans, right? And how much bandwidth we ultimately have. But eventually, we're going to want to go back and try to address problems that we have. And we have to treat those as tech debt. Tech debt's kind of an overload term, can mean a lot of different things, but it's basically work you don't necessarily have to do to ship your product, but perhaps you should do because maybe it makes you more efficient. In this case, it can make you more secure. So your organization may have a mandate of how much of this that it wants to chip away at. Your team might be opportunistic about how it wants to take this on, but it is something that has to be managed independently. And this allows you to focus on doing the best work you can, the most secure work you can on what's under development. So tools provide us feedback. They let us know when to take immediate action. But one of the things, and one of the key things I'd like you to take away from this presentation is that employing tools doesn't make you secure. And it doesn't necessarily mean that you're doing secure development. It means you're using security tools. This is a good thing. But how you use those tools in the context of the software that you're building, what are the processes that you've built around the feedback that these tools give is really essential in being able to maximize the value of the feedback that they're giving you. So security testing. So typically another misconception is, oh, we have SaaS tools in our pipelines, we have SCA tools in our pipeline, we're doing security testing. And yes, those are part of the puzzle, and they're an important part of the puzzle. I don't want to diminish them in that sense, but it's not all that we could be doing. And because there's some things that an automated tool wouldn't be able to find. And I have an example here about repudiation, right? A SaaS tool may not be able to tell that you should be, when this function is called, you should be logging exactly who called that function, so that, because we need an audit trail later on in order to determine if a malicious actor or an insider threat did something that they weren't able to do. A SaaS tool is not going to tell you that. But in threat modeling, if we thought about, hey, there's a possibility that this, method or HTTP method could cause, it has some big implications if someone were to call it or to misuse it. Well, we should make sure we're logging when people are calling it so that we can track that down should it be misused. You would then want to write a unit test or an integration test that actually calls that method, and hey, we can verify that the log line was produced. Okay, if it put it in testing automation, and away we go. And it's really critical to be thinking about, just with anything in software, not only how do we build it, but how do we test it? How do we design something securely? And how do we write tests to guarantee that security that we've written? And again, as mentioned, a lot of these tests you might find during threat modeling, a bunch of examples of different types of security testing that might be out there, depending on the type of application that you're writing. Maybe, network testing matters a lot. Maybe it doesn't matter very much. This will be determined in part by the scoping exercise that you do in threat modeling. And of course, there's the really big one, penetration testing, right? Any of y'all do pen testing? Nice, that's so cool. I think pen testing is so fascinating. And it's like, hey, not only just thinking of bad things happen, but try to, in some cases, make bad things happen. But there's a quote from NITS about what penetration testing is. Typically, this is an annual process. This is like an NI, we procure this about once a year. We generally go with a third party. We generally try to go with different companies year to year as we do this because we want different feedback. And we're actually have a penetration test that is ongoing for our software. And we decided, hey, we're going to take a black box approach to testing. Here's our 3 endpoints. See if you can do something bad. See if you can get in. They couldn't. Pat ourselves on the back. Here's some credentials. Now you can log in. Now that you can log in, there are other vulnerabilities that we should be looking out for. And that's the part of the test that's ongoing now. One of the things to keep in mind, because penetration testing can be really expensive, is, hey, do I feel like we're doing work to be able to identify and remediate things that penetration testing would find? And that's where like DAS tools and stuff come in. Even if you're just running them one-off manually, that feedback that you get could be really important. Because in fact, a lot of pen testers will run those types of automated tools to take a large swath of your application and then laser in on particular hotspots that the tool is perhaps finding things. But yeah, if you have a product that's network accessible, it's UI or it's API, penetration testing is a really good idea. SBOMs. So talking about securing our supply chain, an SBOM is a way of saying, hey, this is what's in our supply chain. This is what our software is made up of. This is our software, so you'd have to bill of materials on the software yourself, you're shipping, and maybe other things like for our software system link. Right now, we produce SBOMs on our containers that we ship, various containers for various dependencies, and of course, we run our own software on. But we need to do more, and this is one of the places that we're maturing our practices. Oh, are we also producing SBOMs for our libraries, the software that's running in our containers, or the SBOMs for our own software itself? And this is really essential because when a vulnerability or an exploit comes up, you really want to know very quickly, am I exposed to this? Log4j is a great example, right? How many of us were like grepping through, version control systems being like, is log4j the string there? Like, I don't know. These types of tools should be able to provide you much more rapid feedback if that's the case. You can imagine that places like the US government, doing the things the US government does, whether it's building a missile or, making sure your social security check goes out, would care about the vulnerability of the software in the supply chain that they're running. So the EU CRA is also big on this, and all products are going to have to begin producing SBOMs. And I believe it's available on request in most cases. But automated tooling, especially SCA tooling, can help out with this a lot because they're already scanning your dependencies and telling you about the feedback you would need in order to determine, oh, should I upgrade this dependency? Can I keep using it? Some of the best software vendors out there right now are very rapidly improving their tooling to be able to produce these SBOMs and manage them. It's not uncommon that you want to do things like include attestations. We were shipping Kafka with our product for a long time, and Kafka just has a huge list of vulnerabilities available to it, but a lot of them were only there or exploitable if you were using particular methods inside of Kafka or some sort of extension of Kafka generally. And if that's the case, you're like, look, we don't actually need to do anything here because we would not be affected by this ever. You provide attestations, and good tools will help us provide attestations and manage them. Perhaps they're suppressing feedback you're getting in a build pipeline. Perhaps it helps you build a report that you'd hand to your customer of what your SBOM is. And if they were to run their own automated scanning against that SBOM and they'd see things that concern them, hopefully there's a report there right away, alleviating those concerns because we have attested that it could not affect us. Of course, those attestations, you can't lie, right? You lie, you're gonna put yourself in legal jeopardy. So that's really important that if you think that something isn't actually going to affect you, you may need to really prove that to yourself. And of course, if I haven't mentioned it earlier, or had it in slide earlier, in cases where there's a vulnerability found in a dependency, and upgrading that dependency will resolve that vulnerability, don't even do the work to see if it affects you or not. Just upgrade the dependency. So last bit, culture, moving along here, being fast. So it's important to establish a security-centric culture. And I think some of the things that I've seen working with my team, especially in the last few months, this is the thing that like warms my heart, is yes, we talk about things that could go wrong in threat modeling, but now we're talking about security every day in all sorts of different scenarios. And building that culture is really essential to make the practice successful long term. So I'm going to pick on IT people a little bit. I have this like gripe. I'm big on security, and then an IT person comes in and says, "Hey, there's a VM that's out of date. Go update it." Or, "Oh, there's a version of Chrome on a VM in your infrastructure that's out of date. Go upgrade it." And we get these like very transactional types of relationships, and it's like, man, the IT person is just constantly bugging me for things that I need to do, and it's annoying, and we don't like those folks, and it's not really fair, right? They're trying to do their absolute best to ensure that in the software and the systems that they have up and running, that they're secure. But that type of transactional nature starts begging a question of like, well, how is it that we have some VM we don't know about that's running an outdated version of Chrome? Like, why is that the case? We might be considering how applying these types of processes like the Secure Development Lifecycle is a way for us to hopefully never be on IT's radar. If you're doing a perfectly good job, you have your own feedback, your own tooling, your own processes to establish this, you're not going to get needled about these types of problems because you're shifted left, you're being as proactive as possible. And so what I want to stress is that that's the outcome that we want. And the way you get that outcome is you get people to care about security. You can't just sit there and be like, look, we're, demerits if you, had something that was vulnerable that was shipped or was running in one of your environments, or we're going to, you need an email from someone you've never met. Like, that's part of security, but it doesn't make for secure products to be operating this way. You need people to deeply care about security and realize and recognize that building software securely is what it means in 2024 to be able to build software professionally. And if you take yourself seriously as a software engineer, you need to be able to take security seriously in what you're doing, and it helps to mitigate all of this. We want to shift left. And so the most critical change, this thing at the bottom, maybe it should be at the top. The most critical change you can make is getting developers to care, getting people to talk about it. Another important thing, again, focusing on the human aspect, is the security champion program. Bunch of good material online. I know Sneak had a good white paper on security champions I'd encourage folks to read. Some of our security champions there in the back. And these are people, right? We're asking people to do a new process. How do we ramp people up on the process? Well, you take folks who are experienced in the process and you embed them, maybe just in a meeting or maybe on their team for a little while to help ramp them up on security practices. So we want these people to be, take it upon themselves. They care a lot about security, so much that they're going to do extra credit in order to learn about application security and what it means to do secure development. We want them to be a constant reminder on their team of security concerns, try to keep that conversation going, advocating for security on the team. And then of course, we want the security champions to meet occasionally. I think we meet bi-weekly now. And the security champions are going to be representing, needs in the team. Hey, we have a team that's doing driver development. You're asking us to do secure development, but the policies for driver development just aren't there. And that's really good feedback. Okay, the SDL governance team and the security champions program collectively might need to figure out, how do we address that? How do we bring in security for this new thing that we're doing? We want to be active group members. You want people to participate. You don't want them just to show up to a meeting and never say anything, never have to do anything. You want to require some level of engagement. So in some cases, if you have a security champion program, you might be tying back people's performance reviews and things like that to activities happening in the program. And lastly, we don't need a hero. We don't want someone who's like, well, hey, this is John's job for security, and the rest of us don't have to worry about it. And John's really killing himself trying to make everything secure and do all of the things. You don't want that. You want to be an advocate. You want to encourage people to care about security themselves. You don't want them to be the one person who has to do all of this themselves. So, suggestions on getting started with this: read. There's so much great material out there on the, things like Microsoft's SDL is a great place to start. Link here. Then trying to write it. If I write, I've learned more about the SDL, understand what the practice is. Could I write down what the process is and how it would apply to my organization? And of course, iterate. No process is perfect. No process is ever totally done, especially when you do an early version of this. You want to keep on iterating on the process in order to be able to make it better and continuously improve it. Once you actually have something, don't forget about training. Training is essential. Make sure people have training before you're asking them to do a totally new process, and start small, right? we want every team, every feature they'd ever build to go through this process. But what do? We start small. There's a new team who's adopting this process, say, take one feature, make it a small feature. Maybe it just seems totally trivial that there shouldn't be any security threats with adding a button. But the reason that we do that is so that they can scope themselves down to something and they can learn. So we want people to be able to grow those muscles about how to do secure development so that when we're asking them suddenly to do things like, hey, we need to support privately signed certificate authorities throughout our entire system, which is a complicated thing. How do we make sure that we're doing that right and doing it securely? Well, we have a bunch of experience to fall back on. And of course, expanding each iteration. So if you had a team that was doing the SDL for something small and trivial in the first iteration, perhaps they're doing it for 2 things and a little bit less trivial in the next iteration, and they just grow that over time until they're doing it for everything. Of course, iteration here, could be anything, 4 weeks, 2 weeks. We think about things on a cycle basis, which is like a 3-month thing, but it doesn't really matter. It's sort of, again, contextualize this to your organization. Hear about barriers, quickly go through these quickly because I know we're very short on time. People thinking like, hey, I have a product that doesn't need security features, doesn't have security features. And again, get back to the point. The SDL is for building secure features, not just security features. So any feature could be exploitable. Any feature this is applicable to. We don't have time to do this, right? Oh man, we're so strapped. We have to hit these deadlines. And the thing is, like, you will find time for that incident response. Folks like Kyle Tetmeyer comes knocking on your cube. You're going to make time for the things that Kyle is concerned with. If we can shift left, maybe we can save time because you're going to be forced to make time should there be a problem. Customers are asking for this? Absolutely. Yes, they're asking for this. A lot of the things that are in the EU CRA were like, man, well, at least we have 36 months to do this. And then a customer walks through the door and they says, you need to do this now. We will not do business with you until you do this now. And that's increasingly what we're finding, that long window that we thought we might have to do a bunch of things, the pressure coming from customers is extreme enough that we're having to rapidly expand this practice in order to ensure that our products remain viable. Lacking security tooling for your product. Yeah, everyone's going to lack security tooling when you first get started with this. Maybe you actually have some of that security tooling in practice. That's great. And that's awesome to have that in your back pocket. But if you don't have that, you can still talk. You can still meet with one another and think about bad things happening. That's really the most critical part. That's the part that makes sure that, oh, this isn't just like feedback I'm getting and it's noise and I don't pay attention to it. Perhaps from like a security tool, it's feedback that I'm getting and it's helping make us better. We know how to react to that feedback. We've discussed what to do when we get that type of feedback, or we don't receive that feedback because we mitigated the problem before it ever happened. Help getting started. Again, that's where things like the Security Champions program and cultivating a program like that helps, especially if you're trying to expand the practice. If you started with one team, as we did on SystemLink, that one team becomes the kernel of the Security Champions program that helps to educate many teams and scale the whole program. Customers care. I think it's the last slide. Cannot stress this enough, that even if you don't think this applies to you or this is something that you maybe need to get to eventually, your customers are going to pull you in this direction. Talk to your sellers, talk to your deal desk team about if they're getting security checklists they're being asked to fill out. It might come to you because you're the expert on your product being asked to fill out a security checklist. The moment that's in there, it's a big signal that security and secure development is essential to keeping your product viable. All right. We're right at time, maybe a couple minutes over. Any questions or anything like that?
Any AI tools that you started using for security threat modeling or anything like that? You started using this code conjure thing that's like examining all of our code and stuff.
I think that AI and large language models are going to be really important to improving the smartness of a lot of the tools that we use. And it's kind of one of these things, but there's such a horse race in AI right now that like, oh, hey, we've adopted Sneak Code to do static analysis. Well, I would be very surprised if Sneak Code doesn't have some AI enhancement that we just sort of get for free because there's such a horse race there. But that's my expectation, at least over the next 18 to 24 months. Good question.
Have you done any analysis like the shift left, like actually reducing friction in work of like by doing secure code from the start, you've now had X amount less incidents and saved X amount of time?
Probably not. And I think part of the reason for this, and Kyle might be able to speak to this, is that the amount of work going into research to identify CVEs is increasing. So we're seeing this sort of dual pressure of there's a lot more people paying attention to the security of things and reporting security at the same time that we're trying to do more secure development. So it's a little bit of perhaps maybe it's a zero-sum game. You know, it always seems like there's more CVEs even as we're getting more secure. So it's really hard to draw like a hard one-to-one relationship to that. But clearly, there are things that you're doing that you know about your software that you could mitigate. That, say, if a security researcher knew, it would definitely be a CVE. Those are the types of things that you could address.
You got someone on chat.
Oh, is there someone on chat?
Yeah, this is Seth, if you're able to hear me. Great presentation. I was going to ask about security champions until it came up at the end of the presentation, but I would just ask, if you were establishing a team of security champions, perhaps because you don't have the security headcount to embed in every development team, and you wanted them to facilitate the secure development lifecycle. I think it was mentioned training earlier, but I'd just love to get your thoughts on the training that you would want to have for those champions, and then maybe any frameworks, tools, product services you might recommend to deliver that training. You might envision badges or something else that people receive after passing certain assessments that then bestow upon them the potential designation of a champion, as an example.
So those are interesting ideas. The gamification stuff is actually a really interesting idea. But we are working to try to make more training available to our security champions than just the general population of our development teams. So there is that part of it. And I'll admit, there's a lot of really incredible training resources out there, and usually the best ones are paid for. There's more general ones like LinkedIn or Pluralsight and stuff like that that will have a lot of material for training. But there's also companies like Security Journey that produces just security training. And actually, they have a whole built-in gamification part to it. But all these things come with a cost. And I think one of the things that we're working on at NI is being able to ensure that we can communicate the ROI of acquiring third-party training and the benefit that it'll apply for our teams. So we try to strike a balance, some material that we are developing internally for ourselves, but we're constantly looking at external for training resources.
Fantastic. Yeah, they were on my radar. Thank you.
Okay.
Great presentation. How are you measuring that your teams are following all the controls and all the best practices?
Yeah, and this is actually where compliance and stuff comes in, which is always something I shiver at. Oh, you want people to care, but I think ultimately you need to check with things like compliance, and this is where it becomes useful. Can we tell that people are employing particular tools? Could we go in and ask a team, hey, we'd like to be able to see your threat models? And that's very much the type of compliance you might expect the EU to do. They'd probably hire a third party to go and audit you, prove that you're doing secure development. Oh, well, I might have to pull up a high-level design, and here's the threat model, and here's the things that we said that we would do about it, and that's how we go and do it. Perhaps you need to do this internally. This is also a thing what security champions are effective with. Hey, we want security champions to be embedded on just about every team. This might be the first group that we go and take the temperature of the entire company to be like, how are people doing? Are they struggling with ramping up on this? Do they need additional help? Do they need additional training? There's soft ways and hard ways to be able to go after that type of compliance.
I'm just going to mention in conversation with both of you that I participated in a team for a district bank that had actually a premature software security risk management program, and that was a dedicated function within the bank working with enterprise architecture and sitting in information security architecture to do that, and running up to about 50 different quarterly assessments to capture the maturity practices.
Yeah. But critical for highly regulated industries like banking, right, or medical. You might find that there's more requirements that you must meet in order to be able to prove that. And actually, sometimes it can be nice to go provide guidance on what you need to do in order to prove that compliance.
Great job, by the way.
Great questions. Yes, go ahead.
So somebody earlier talked about AI, and most of the times we're looking at AI for security, when securing AI itself is crucially important.
Right.
As well. So Alaska has got a lot of good training that's coming up, and I'm going to do my shameless plug over here. So
Nice.
I'm doing a one-day workshop at LastCon over here for securing AI. So if anybody's interested, you guys can sign up for it through OAS.
Awesome.
With respect to your presentation, again, very good presentation. Two things. One is from a SDL standpoint, most of the time, most organizations will see go from requirements to release, and then incident response being kind of a subset of that. Rarely do we see retirement. So how do you handle end of life? You know, with an agile framework, you have these continuous CI/CD pipelines that kind of you maintain versions. But if you're shipping products and this being under product security, so the two questions is one is how does end of life factor into your life cycle? If it isn't, that's fine. But, and secondly, you mentioned customers 3 times throughout your presentation, and how do you attest not the existence of controls, but the effectiveness of your controls to your customers?
Yeah, so I'll admit, I don't think we've thought enough about end of life. And that might be an area where we say, look, we lack maturity and we need to reason through that and then try to grow the maturity there. So it's a really good point, something for us probably to be thinking more about. I know things like the EU CRA is going to require an N-5 year security update policy for software. This is having us have to think a lot about how are we actually going to accomplish that, right? My software ships every month. What does that mean? Like after 60 versions, I'd have to build a security patch. So we're still interpreting that and even working with legal teams to be able to understand that. The second part of your question, oh yeah, so that's actually really interesting. So I'm working with one customer right now where they have a very thorough security checklist, and luckily at this point we were able to answer affirmatively to most things, although not everything. But one of the things that they're asking for is for us to actually go and prove it. Like show us the documentation that says how to secure it configure something securely. And sometimes they might be like, hey, we're okay if that being internal documentation. Maybe we need to like screen share or something with them. But that is kind of a human process at the moment to do that. But it is exemplary of customers getting more and more strict about this and having higher and higher expectations. You can't just attest. You might have to be able to, trust and verify kind of thing. A very good question.
As a part of Shift Left, would you include QA in your threat modeling sessions, or is that overboard?
No, I think you should, because I think how you do testing for these things is important as well, right? As I mentioned, like, hey, if we identify a threat and we want to mitigate it by doing whatever, can we write a test to be able to prove that? And I think if you have dedicated QA departments, that's perhaps where they might be coming in and providing you feedback on, hey, to write good tests, we need to do these types of things. So yeah, I think software development is a team sport. And I think where threats come from or the ability to think of bad things happen can come from anyone. Perhaps there's someone on the QA team who's really good at thinking about that. You don't want to exclude someone who might be valuable in that sense. Great.
Excellent presentation.
Thank you. Thank you. Stop the recording then, okay?